But let's talk about drawing modulus graphs as well. So we saw in last lesson, and you'll see that I've recorded this before last lesson, but we saw in last lesson that the graph of modulus of x is kind of like an upside down triangle. And in investigation 9, it showed us that the cusp, that point where would be the apex of the triangle, occurs at hk, and a determines how narrow or wide the modulus function is. Now, we've been asked to find the domain and range of y equals the modulus of 2 take 2x plus 1, but it doesn't take the form ax take h plus k. But we can convert it into that form. And the rule that the modulus of a times b the modulus can be split into both those factors, so modulus of a times modulus of b is going to help us. Now, y is equal to the modulus of 2 take 2x plus 1. The first thing I notice is that x has a coefficient of 1, and the coefficient is positive 1, not negative 1. So really we want to take out a common factor of minus 2 to get the coefficient of x being 1. Now I'll rearrange it first, so it's minus 2x plus 2, and then I'll say, okay, well that's a modulus of minus 2, and that will leave me with an x inside the bracket, and then if I take out minus 2 on this second term, I'll get take 1, because when minus 2 times minus 1, the product of those two gives me positive 2 plus 1. Now I'm ready for my rule. I can write it as the modulus of minus 2 times by the modulus of x take 1, because these two were multiplied, and I can split the modulus up across a multiplication. Now the modulus of minus 2 is just 2, so it'll be 2 modulus of x take 1 plus 1. So my cusp occurs at 1, 1. Now, so I'll just write that down, cusp at 1, 1. Now, we saw that it was narrower or wider, but this 2 tells me a lot more. Firstly, because it's positive, it tells me that it's upward facing. The second thing it tells me that the slopes of both lines are 2 or minus 2. It's that specific. Whereas in a quadratic, the value of a didn't tell us too much about the slope. It talked about being narrower and wider and being positive. Because we're working with straight lines in this case, it actually gives us the slope of the straight lines. So I know I'm going upward from this point 1, 1, but I also know that if I go across 1, I've gone up 2. And if I go across 1 the other way, I've also gone up 2. So I can just draw that. And I'll do it as accurately as I can. And the same on this side, as accurately as I can. But using the slope will really help you get it accurate. And so it is that specific that the value of a will tell you will tell you the slope. Now in this case, the slope here is minus 2. And in this case, the slope is 2. But that comes directly from the fact that the slope, or the value at the front, is 2. Now, we're asked to draw, this time, the graph of the modulus of a quadratic. Now, we can't get this in the form a x take h plus k, but the definition of a modulus tells us that wherever the value of the function is positive, it will just be the same, it won't change, and wherever it's negative, it will just become the positive version of that value. So let's start by just finding all the key points of the quadratic. And then whatever's negative, we can just make positive. So the x-intercepts, I've got to solve x squared plus 7x plus 10 equals 0. So that factorizes to x plus 5, x plus 2. And so then minus 5 and minus 2 are my x-intercepts. So I'll write them in coordinate form. My y-intercept is when x equals 0. So that's just the point 0, 10. Because when x is 0, x squared and 7x will be 0, and so I'll get left with 10. And the axis of symmetry is halfway between my roots. So it's minus 5 plus minus 2 divided by 2, which is minus 5. Take 2 on 2, which is minus 3.5. Minus 7 divided by 2 is minus 3.5. Now if I plug that back in, I'm going to plug it into factored form in the hope that that will be easier to work with. So I can't guarantee it. So minus 7 on 2 plus 5, well that's minus 17 on 2 because 5 is 10 on 2. And minus 7 on 2 plus 4 on 2, hang on, minus 7 on 2 plus 10 on 2 is definitely not minus 17. That is positive 3 on 2. So perhaps I'll put an extra line in here, maybe that might have helped me get it right. And then minus 7 on 2 plus 4 on 2 is minus 3 on 2, which is positive 9 on 4. And so the vertex is minus 7 on 2, 9 on 4, which in decimal form is minus 3.5 and 2.1, 2.25 or 2.25. Okay, alright, so x-intercepts were minus 5 and minus 2. So minus 2 is there, minus 5 is there. Let's worry about the vertex in a second. 0 and 10 is my y-intercept. So the graph is going to go up to 10 by going 2 to the left. Now by symmetry, if I go 2 to the left, or rather 2 to the right, I've gone up 10. If I go 2 to the left from minus 5, I must have also gone up to 10. So I can plot that point there using symmetry. And that gives me part of my graph. Gives me that bit. And it gives me that bit. Now the bit in between is where it's negative. The vertex, now that should be negative 9 on 4 because it's where our x values are, or rather it's where our y coordinates are negative. So, and that's the key. So the actual point that we want to draw though is where is going to be negative 7 on 2, 9 on 4. So where the y coordinate is positive. So if I go to negative 3.5, that's going to be there. And up to 2.25 is going to be about there. Now, it's a matter of then just drawing the points. So we know that the quadratic has a curved shape around the vertex. And so it is just a reflection of what would have been below the x-axis in the x-axis. So it's just reflection of the graph around the vertex in the x-axis. Okay, and we're going to leave that there.